Hello everyone. Today we are going to see the topic name called image-based diagnosis of thyroid disorders. So in our project is all about detecting thyroid disease automatically using image processing and deep learning. So in this project we created an automated system that looks at thyroid gland images and predicts whether the person has normal thyroid, hypothyroid or hyperthyroid. So here we use the model convolutional neural network, which is nothing but a CNN. So it is a type of network, deep learning network. So that works especially well for images. The CNN learns patterns, shapes, and textures from the thyroid images to make it predictions. After that, the trained model we are using and integrating with the Flash scriptage. So now we will move on to the block diagram. So this is our block diagram. First we are taking images and then we are pre-processing that image. Like we are reshaping that images and then based on that image we are extracting features using CNN and then we classify that thing like it is a normal thyroid, hypothyroid or a hyperthyroid and then result will be shown here and then we are integrating that with the web interface Flask and then we are storing our database. For that we are using SQLite and then at the last we are able to see the output. Our training code, first we are importing all the necessary libraries. So this is our data set part. Here we have our data set. So we have actually three types of data sets. So this is our data set. And then we are using data augmentation. Data augmentation is nothing. It is like we are rotating and then reshaping that images for better accuracy. Then we are so here we are splitting our data set for 80% training and 20% for testing purpose. And then we are using class indices. Why we are using this means we have three types of class. For each types we are giving one numbers like zeros, one, two, like that. So here we are building our CNN model. For that we are using sequential model. And then we are in here we are reshaping our images like 182 pixels. And then we are flattening. Flattening means we are converting 2D features into 1D array. And then we are using categorical concentraphy. So why we are using this? This here means we have this is used for a multiple classes. We have three types of classes. For that we are using this thing. And then in this place, we are saving our model. So our model is saved as thyroid underscore CNN underscore model underscore three class dot H5 extension. And then we are training here with the epoch of 25. So at last we are saved model. So this is our testing code. Here also we are importing all the necessary libraries. So here we are loading our trained models and class indices. And then here we are predicting the thyroid. So first we are taking the image and then we resize that image into 128 pixels and based on that image, it will predict. And so here we are using Tinkercad GUI. So here we select that image and that image file, it will supports JPG and PNG files. And if we upload that image means, and then it will resize, like it will pre-process and predict. And along with the prediction, it will give the confidence. So this is our app.py code. So whatever we did in the testing code, same only we are doing here. What we are extra doing means we are integrating our routers. So first we are importing all the libraries and then we are creating a Flask setup and then this is database connection. So here we are storing our ID, name, email, password in the database. So here we are loading our modules like a thyroid model and class indices for predicting our disease. So this is index router, about router, contact router. This is a registration router. First we need to register with our name, email, password. After registration, we will redirect to the login page. After registration, our data will be stored in the database. So this is our login page. So this is our login. So for login, we need to provide email and password. After login, we will redirect to our prediction page. In that prediction page, we need to upload that image. Based on that image, it will pre-process and then pre-processed image is given to our model. So our model will predict the disease. So this is our logout router. This is prediction router. So we need to open the terminal and we need to give Python space app.py. This is our file. After that, we will get online. We need to follow that link for web page. This is our web page. Here we have buttons like login, register, about, contact, and predictions. So first we need to register. After registration, we need to log in. So after login, we will redirect to our prediction page. This is our prediction page. First, we need to choose the image. So this is our data set. Here we have three classes, benign, malignant, and normal. So if we click that image, and then we need to click analyze image, but as a normal and confident is 99.63%. Then we will test with the other classes also. So this is a malignant and confidence 100%. So this is benign and confidence 98% percentage. So we will go back to home. So this is our about page about the project like data sets, see what are the models we are used, how it predicts, and then our GUI. These are explained here. So if I click back means we will go on to their main page. So this is our contact. So if you have any queries means here you can contact. You can directly once after register and login, you can directly go here also for prediction. Thank you.